In this prep assignment, we'll review the principles of volumetric analysis and introduce some new types of titrations. Recall that the equivalence point occurs when the amount of titrant is exactly equal to the amount needed to completely react with the analyte. We're most familiar with this concept in acid-base titrations, but here we see an example where we'd need to add 2 moles of the highly colored purple permanganate ion for every 5 moles of our oxalic acid solution. The endpoint of this particular titration is made known by the persistence of that strong purple color once all the oxalic acid has been consumed and the permanganate ion begins to build up in solution. The difference between the equivalence point and the endpoint can lead to a titration error. In this example, we may add too much permanganate before we realize the solution is showing signs of the compound no longer having anything to react with. A blank titration can help us minimize the titration error by answering the question, how much permanganate do I need to add to the solution before I can detect the purple color? Both the regular titration with oxalic acid present and the blank titration without the oxalic acid are examples of direct titrations. We're going to add titrant to the analyte until the endpoint is observed. Ideally, we'll work with primary standards, which are reagents pure enough to use directly without having to account for impurities. Sometimes we have to work with compounds that are not as pure as we'd like, such as sodium hydroxide. Sodium hydroxide is notorious for pulling moisture out of the atmosphere so quickly that you can literally watch it gain weight and a sweaty appearance on the balance pan. Sounds kind of like my feeble attempts at going to the gym. Jeez. When we have to work with an impure standard, we may have to standardize it to determine the actual concentration of titrant present. Once we've done that, we can prepare our standard solutions since we'll know the concentration of the titrant for sure. Another type of titration is the back titration. In this example, an excess of oxalic acid, in blue, is added to peroxydisulfuric acid, and this excess of oxalic acid is going to push this reaction all the way to completion, giving us 2 moles of sulfuric acid and 2 moles of carbon dioxide, which are driven off because this is done at a higher temperature. So if we're using an excess of oxalic acid, how do we figure out how much of this peroxy acid was present in the first place? That's where we're going to do this back titration using permanganate. Remember that permanganate had that gorgeous purple color, and whenever that purple color begins to persist, we know that we've run out of our oxalic acid. This will tell us how much excess oxalic acid there was, and we can subtract it from the total amount of oxalic acid that we used in our titration. The difference we can then convert to moles of the peroxy acid that were present initially. In our final type of titration, we see that when we measure a titrant by mass rather than by volume, this is considered a gravimetric titration. While this is touted as the gold standard of titrations, I have yet to see any examples of this put into regular practice, especially in the teaching lab.